Identify the image of point 4 and negative 2 after a dilation of 3. A. 1 and negative 5, B. 12 and negative 6, C. 7 and 1, D. 4 over 3 and negative 2 over 3. To find the image of the point after dilation of 3, what you have to do is to multiply 3 to x coordinate and y coordinate. First step, we're going to write 3 and 4, negative 2. Then we're going to distribute 3 times 4, 3 times negative 2. So 3 times 4 is 12. And 3 times negative 2, which is negative 6. Our final answer is B.
The question here is asking what is the measure of TRU in the triangle given below. Here we see that RS, RT, and TU are all equal, given that the angle RTS is 50. Seeing here we have a straight line. This angle is equal to 50, meaning that this angle here needs to add up to 180, which will be 130. Because this angle is 130, we need to find the angle TRU, which is this angle here. These two lines indicate that these angles are parallel. So the angle that we're looking for and the angle here are both parallel, meaning they are going to be equal. Because this angle here is 130, these two angles here need to add up to 50, because an angle in a triangle is 180. And as we have 130, again, it's gonna equal to 50 for both of these angles. So dividing it by 2 will give us 25, which will be this answer.
In the accompanying diagram, triangle ABC is inscripted in circle 0, and the line segment between A and B is a diameter. What is the number of degree in measure angle C? As you may know that the angle at the circumference in a semicircle is equal to 90 degrees. And here, angle C is in a semicircle. So that makes the measure of angle C equals to 90 degrees. Thank you.
What is the area of base of a triangular pyramid with a volume of 88 centimeters cube and a height of 16 centimeters? The given here is volume of 88 centimeters cube, height 16 centimeters. We are asked here to find the area of base. Area of base isn't given. Now, the volume of triangular pyramid is given by the following formula, which is volume equals 1 over 3 times area of base times height. Plug in the given, which we have. The volume is 88 equals 1 over 3 times area of base, since it's not given, times the height, 16. Now to find the area of base, we can combine between 16 and 1 over 3 to be one fraction. It would be 88 equals 16 over 3 times area of base. To get rid of 16 over 3, multiply each side by 3 over 6. Multiplying it by 3 over 16, and 3 over 16. Now, 16 and 16 will cancel out, and 3 and 3 will cancel out. We will be left over with area of base. So, area of base equals 3 times 88 over 16. Which equals to 16.5 centimeters square. The correct option is A, 16.5 centimeters square.
diagram below, the right triangle ABC has legs whose length are 4 and 6. What is the volume of the three-dimensional object formed by continuously rotating triangle about AB? We have the length, which is 4 and 6, and it's asking for the volume of the three-dimensional object continuously rotating. So I'll be showing you a 3D dimensional in GeoGebra in a minute, but first we're gonna have to work out in pi, so we have to take that in mind. Showing you a visual explanation of how to work out the volume of this triangle constantly rotating. As you can see, if we start rotating this triangle, let's do it a bit slower. Okay, if it constantly rotates, we are going to have a cone, as you can see here. So the question is asking for the volume of this triangle constantly moving, which means it will give us a cone. So we need to find out the volume of this cone. As the question says, our radius is 4 and our height is 6. I'm going to be showing you here where is the radius and where is the height. The radius of the cone starts from here to the end point of the circle on the bottom of the cone, and the height is in the middle to the very top of the cone. Going back to the formula, we are going to substitute the r in the formula with our radius, which is 4, and our h with 6, which is our height. So it's going to be volume equals pi times 4 squared times 6 over 3. Putting this in our calculator will leave us with the answer 32 pi, and it's answer A.
A series of transformations on quadrilateral S resulted in quadrilateral T. The angle measures of quadrilateral T are congruent to those of quadrilateral S. The side lengths of quadrilateral T are twice as long as those of quadrilateral S. So, which transformation on quadrilateral S must be included to result in quadrilateral T? So, is it a dilation, a reflection, a translation, or a rotation? A dilation is a transformation that produces an image that is the same shape as the original, but in a different size. Compared to a reflection, a translation, and a rotation, they don't change the shape or the size. So as we can see here, it says the side lengths of quadrilateral T are twice as long as those of quadrilateral S. So the size has changed. So that's why it will be a dilation.
Which of the following figures is not a polygon? Hexagon, circle, rhombus, or triangle? First of all, what's a polygon? A polygon is a figure with at least 3 straight sides and angles. So the only shape here that does not have any sides or angles is the circle. So the circle will be the answer.
For the following right triangle, find the side length x. So we're going to use the Pythagoras theorem to answer this question. So first we're going to form an equation from Pythagoras theorem, which is a square plus b square is equal to c square. So this will be considered as A, and this as B, and this is C. So now we're going to replace the letters by the numbers. So it's gonna be 6 squared plus 4 squared equal x squared. So 6 squared is 36 plus 16 equals x squared. And now we're going to add both of them together, so it's gonna be 52 equal to x squared. Now to remove the square, we have to do the square root. So we're gonna use the square root on both sides. So x is going to equal 7.21. So this is the right answer.
Which rotation about its center will map a regular decagon? So decagon is the plan figure which has 10 numbers of sides. 5, 6, 7, 8, 9, 10. So when we say each side has 10 and equal in measure, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We will cover a complete rotation and angle as 360 degrees. This is the center of the regular decagon. So is starting from this point and rotated one by one. So sorry, let's pretend that this is the decagon is starting from this point. Rotated one by one. So let's pretend that this 36 degree and 36 degree and so on. So now we have to divide whenever the option giving as an angle and which answer gives you the integer value. So we will divide the first option with 36. We will see what answer will give. 7. 7 is an integer number. That's correct. Let's see the other one. 198 over 36 will give us 5.5. It's not an integer number. And the option 3, 162 over 36 equals 4.5, and this is wrong. The last question, 54 over 36 equals 1.5, and it's not integer number, so the correct answer is A.
In the diagram below, the right triangle ABC has legs whose length are 4 and 6. What is the volume of the three-dimensional object formed by continuously rotating triangle about AB? We have the length, which is 4 and 6, and it's asking for the volume of the three-dimensional object continuously rotating. So I'll be showing you a 3D dimensional in GeoGebra in a minute, but first we're gonna have to work out in pi, so we have to take that in mind. Showing you a visual explanation of how to work out the volume of this triangle constantly rotating. As you can see, if we start rotating this triangle, let's do it a bit slower. Okay, if it constantly rotates, we are going to have a cone, as you can see here. So the question is asking for the volume of this triangle constantly moving, which means it will give us a cone. So we need to find out the volume of this cone. As the question says, our radius is 4 and our height is 6. I'm going to be showing you here where is the radius and where is the height. The radius of the cone starts from here to the end point of the circle on the bottom of the cone, and the height is in the middle to the very top of the cone. Going back to the formula, we are going to substitute the r in the formula with our radius, which is 4, and our h with 6, which is our height. So it's going to be volume equals pi times 4 squared times 6 over 3. Putting this in our calculator will leave us with the answer 32 pi, and it's answer A.
Diagram below shows circle O with the radii OA and OB. The measure of angle AOB is 120 degrees and the length of the radius is 6 centimeters. Which expression represents the length of the arc AB in centimeters? So we can see here we have a curve. So the curve here is known as the arc length, the arc of AB. And now what we need to do is to use the formula of the arc length. So what does the formula says? S equals. So what does S mean? S is the arc length. It's the distance between point A and point B around the edge of the circle. So time equals theta. So theta is the central angle in radians times r, which is the distance between O and B, as we can see here. So now what we need to do is to convert theta from degrees to radians. To do that, we will multiply it by pi divided by 180. So we will divide it by pi over 180. So it will be theta equals 120 degrees times pi over 180. So it will be, we have here 120 times pi over 180. So here we can cancel the zeros. So I have to cancel here 0 and here 0. So if we cancel the zeros, it will be 12 over 18, and here we have pi. So 12 pi over 18. So 12 here is also known as 6 times 2, and the 18 is also known as 6 times 3. So 6 times 2 equals 12, and I'm gonna leave the pi here, and then over 6 times 3, which is 18. And now we can cancel the 6. As we can see here, we have 6 up and 6 down. So theta, I'm gonna write it up, theta equals 2 pi, as we can see here, 2 pi left up over what's left down is only 3, so 2 pi over 3. Now we will find the arc length. So I'm gonna write it here. So as I said, the arc length formula is S. So S is the arc length equals theta times R. So here we find theta, which is 2 pi over 3. So 2 pi over 3 times R, which is the point between A and B, as I said, so it's 6. And now we will multiply 6 by 2, which will give us 12. And then I'm gonna keep the pi as it is. So as here I multiply it by 2, and here we have over, so the 3 here, it will be over 1 because I multiplied here, so it's going to be 1 over 3, 12 pi. So which answer is it? It's this one.
The length of an arc is 18 centimeters and the radius of the circle is 6 centimeters. What is the radian measure of the central angle? So to solve this question, first we need to see what's given and what's required. So what's given to us here is the length of the arc, which is 18 centimeters, and the radius of the circle, which is 6 centimeters. So here we write arc length equals 18 centimeters, and r, which is the radius of the circle, equals 6 centimeters. And what's required is the radian measure of the central angle. So first we start by writing the equation, which is theta equals to the arc length, which is s, divided by r, which is the radius of the circle. So it equals to the arc length, which is here, 18 centimeters, divided by the radius here, which is 6. So the radian measure of the central angle equals 3 radian. A central angle measures 4.5 radians and has an arc of 35 inches. What is the radius of the circle? So what's given to us here is 4.5 radians and the arc length, which is 35 inches. So we start by writing them here, the arc length, which equals to 35 inches, and the radians, which equals to 4.5. And what's required here is the radius. So we start by writing the equation, which is radius equals the arc length over the radian. So r equals to 35 over 4.5, and the answer is going to be 7.78 inches, which is our radius.
Yes, so here I'm going to be solving these two questions. So first of all, find the length of each arc, round to the nearest tenth. So first of all, the formula to find the length of an arc is S, which represents the arc, equals R times theta. And what does theta represent? Theta represents over here, this little central angle, which is 110% in this equation, but the central angle, or the minor arc, minor angle, that is theta, and that is what we have to multiply with the radius in order to get the length of our arc. But one thing we have to do before we do that, because they usually give those central angles in terms of degrees, what we have to do is we have to convert that into radians. So what we're going to do first is convert that. So 110 degrees, how we convert that, I already made a video before. You just have to do it in terms of pi over 180. So what we have to do first you could do it however you like, whatever sequence you want to follow. So first I'll just simplify these. That's all we can simplify. So 11 over 18 into pi. So I will multiply 11, let me just open my calculator. 11 times 3.14, which represents pi, 3.14, that is 34.54, and then divided by 18, that is 1.91888, yada, yada, yada. I'm just going to round that to 1.9. So approximately, this equals 1.9 radians. So now we're going to plug that into our formula. So the arc equals 4 radius times 1.9 radians. So now if we do that in the calculator, so 1.9 times 4, that equals to 7.6. So that is how much our arc of this red one over here, the arc, that's its length. So over here they're saying, find the length of each arc, round to the nearest tenth.
Here we have a question from the EmSAT. It says, which of the following radian measures is equal to 56 degrees? So here we need to change 56 degrees to radians. And this is how we do it. 56, we divide it by 180, and we multiply it by pi, which equals 14 over 45 multiplied by pi. So the answer is 14 pi over 45, which is B.
Which of the following radian measure is equal to 56 degree? So here we will write 56 degree time pi over 180, which is equal 14 over 45. So this is the answer, equal 14 pi over 45. So this is the right answer.
The question says if sine theta equals negative square root of 3 over 4 and theta is located in the fourth quadrant, what is cosine theta? So we know that the equation is cosine squared theta plus sine squared theta equals 1. In this case, we need to find cosine. So what we're going to do is we're going to put sine here. It's going to be cosine squared theta equals 1 negative sine squared theta. And now you're going to begin solving. So here you're going to put 1. You're going to put sine in a bracket. Squared. You're going to put this in your calculator and you're going to get 13 over 16. So you are going to do square root of 13 over 16 and you're gonna get square root of 13 over 4. That's gonna be your final answer. Cosine is in the fourth quadrant and so it's gonna be positive. So your answer is gonna be B.
If sine theta equals negative square root of 3 over 4 and theta terminates in the fourth quadrant, what is cosine theta? So for this question, we will use the Pythagorean identity formula, which is sine squared of theta plus cosine squared of theta equals 1. The first step is you want to move sine to the other side and start from there. So you would have cosine squared of theta equals 1 minus sine squared of theta. So now you would want to write the fraction you've been given. Instead of sine squared theta, put down your parentheses and write the fraction. So negative square root of 3 over 4 and squared. If you put this in your calculator, you would get 13 over 16. This is not your final answer. So now you want cosine only. You don't want cosine squared. So how to do that is you square root your answer. So it would be cosine theta equals positive or negative square root of 13 over 16, which will give you square root of 13 over 4. This is your final answer. Since the terminal side of theta is in the fourth quadrant, the cosine would be positive.